Okay, so this section is on multiplying a polynomial by a monomial. What did we say yesterday a polynomial is? Many numbers, many terms. We're going to take many terms and we're going to multiply them by a monomial. Do you know what a monomial is? We talked about those. Give you a hint, that prefix there tells you.
One number.
Mono means one, doesn't it? We're going to take a big expression, we're going to multiply it by one term. Which really, you guys have done this. Just the difference is today we are going to be using variables instead of numbers. In this example here, you don't need to necessarily draw this, but it says find the area of the swimming pool below. How do you find the area of any rectangular figure? Length times width. And in our case, it doesn't really matter which side we call length and which we call width, does it? I'm going to call this our length and this our width. It doesn't really matter. So let's substitute in the values that we know. Our length is x times our width. What's our width? X plus 14. Now, we need to make sure we're using parentheses because we are substituting in more than one value. Could you distribute and simplify this right here? That's what we're doing today, simplifying. So x times x is? X times x is x? Squared. Remember when you multiply, you add the exponents. PMA, remember that? Multiply, you add. Multiply, you add. X times 14 is? 14x. So can I combine x squared plus 14x and say that 14x cubed? Why? They're not like terms. Very good. This would be our answer. We don't actually know what x is. We don't know the value of x, so we couldn't find the actual numerical area of this pool. How about this example here? Could you simplify this? We should be able to fairly easily. We're going to take negative 3x times each of these values. So let's start by taking negative 3x squared times 7x squared. Negative 3 times 7 is negative 21. X to what power? What do we do to those exponents? Add them. X to the fourth. Negative 3x times negative x. Well, really there's a negative 1 there. So negative 3 times negative 1 is positive 3. X to the, good, Chris, x cubed. Negative 3x squared times 4. Negative 12 x squared. Are any of these terms considered like terms that we can combine them? No, they all have different exponents. Same variable, different exponents. So this is as far as we could go. I'll give you a second to write this one down. Notice that this one has more than one variable, doesn't it? And that's okay. Sometimes that'll happen. In this case, what value are we distributing? Okay, so 5a squared times negative 4a squared is negative 20a to the fourth. When we're multiplying, we add the exponents. 5a squared times 2x is positive 10a squared x. Now somebody might say, well, those aren't like terms. Why can we do that? Now remember, you can multiply anything. Like terms does not apply to multiplication. Like terms only applies to what? What's it? Like terms. It only applies to addition and subtraction. That's it. You can multiply anything you want. You can divide anything you want. You just can't add or subtract. So like terms. Let's keep going here. 5a squared times negative 7 is negative 35a squared. Do we have any like terms here? A squared and a to the fourth, are those considered like terms? Nope. This is as far as we can go. See what else we got on. Put this one. I'll give you a second to copy it into your notes. Now in this case, we have two separate expressions to simplify, am I right? Throughout the first parenthesis, what are we going to distribute? 3. So let's do that first. Let's distribute the 3 through the first parenthesis. So 3 times 5x squared, 15x squared. 3 times 2x, and 3 times negative 4, negative 12. What are we going to distribute through the second parenthesis? Okay. So negative x times 7x squared is negative 7x cubed. Add those exponents. Negative x times 2x, good, negative 2x squared. And negative x times negative 3, positive 3x. Now we've got this big, long expression. Are any of these considered like terms? Can we add any of these terms together? Absolutely. Let me give you a suggestion, which I think some of you guys are accidentally forgetting terms. You're not intending to do it. You're accidentally forgetting terms. I want you to underline. As you use them, underline them or circle them so that you know what you've used and what you haven't. So we have 15x squared. Is there anything I can add to 15x squared? Okay. So what is 15x squared minus 2x squared? 13x squared. So now we can cross those off to show that we've used those. It's going to help you just to eliminate any accidental forgetfulness. What about 6x? Is there anything to add to that? Positive 3x. So 6x plus 3x is 9x. So I've used the x terms. Now go to the next. We have negative 12. Anything to add to that? No, negative 12. What about x cubed? Negative 7x cubed. No, so I'm just going to bring that down. Now yesterday we did talk about putting it in order, in descending order, if there's just one variable. Let's do that. Let's put our negative 7x cubed first. And then we can have 13x squared second. 9x third. And then negative 12. Kaylin, yesterday we said we want to go in descending order, starting with the highest exponent and working our way down. So we have 3, 2, 1, and this one's an exponent of 0. And that should be our final answer. What else I've got here? I mean, okay. Let me verify this is the right one here. Yep, this is it. Page 442, 18 to 29, and 43. You're adding. So 3 squared plus 4 squared. Let me stop this video.